Good morning, students, and welcome to my YouTube channel. In this course, we will be learning physics. Let me write that down. Physics, entire physics for JEE level. Okay, so without further ado, let's just get started, get right into it. So, first topic for today is basic mathematics. Before we actually get into physics, we need to know the language of physics, which is mathematics. And there are some basic equations, basic theorems that we need to know before we can start with actual core physics. So we can start with some very elementary algebra, which was taught to us in, say, 8th grade, 9th grade, and so on. And we are all familiar with these formulae. And I know this might sound very childish, but let's not skip any part right now. We will do a complete course. So we are familiar with this formula, the square of a plus b and a minus b. Next is the square of three variables, which is a square plus b square plus c square plus 2. AB plus BC plus C. Feel free to skip this part if you're already familiar with it, but this is an essential recap. I'm sorry, A minus B is equal to A square minus B square. Then A plus B, the whole cube, is equal to A cube plus B cube plus 3AB A plus B. Similarly, A minus B, the whole cube, is A cube plus B cube minus 3AB A minus B. Just replacing B with minus B everywhere. And then we have this important formula, A cube plus B cube, this part, and we take the everything else, the other side, and rearrange it a little bit. Then we have A plus B, A square plus B square minus AB. Similarly, A cube minus B cube is A minus B, A square plus B square plus AB. Again, we just replaced B with minus B. So these are two very important formulae which will be used every now and then. Not a lot, but you will see it somewhere down the line. Okay, now that this part is over, which are common formulae, let us start with polynomials. I think we're all aware of what polynomials are. Polynomials are simply equations which are of the following type. So P of x is equal to, okay, let me write in black, or blue is good, a naught plus a1x, let me zoom out a little bit, a2x square, a3x cube, and so on all the way until an x raised to n. So a polynomial is of the form where all the terms have the powers of x, numerical powers of x, which are positive integers or even 0, non-negative integers in fact. And this is the standard form of a polynomial. And if all the numbers, all the a numbers, which is a naught, a1, a2, which we can denote as ai in general, if they are all real numbers, then this entire polynomial is called a real polynomial. Now, we can talk about degree of a polynomial, and as we can see, degree is the highest power of x available in this equation. So this one is this is just n in this case. So I can just give you a simple question wherein you have to find out the degree of a polynomial, and I'll just write it down. So we can name the polynomial anything. I've named it P here. So let's name it f of x is equal to x minus x cubed plus 2x square. So again, this is very simple. The degree of the polynomial is simply 3. Okay. So this is the case of a single variable polynomial. The only variable is x, but we can also have multiple variable polynomials such as f of x comma y. So there are two variables present in this. It's x squared y squared plus 5x cubed minus 2y z. Okay, in that case we would also have to add z, so let's leave the z part out. Okay, so in this case, what is the highest power? So in this case we just add all the powers of the in the variables of a single term. So in this case we will use this term, and this 2 plus 2 is 4, this is just 3, and this is just 1, so the answer is 4. Okay, so now let us look at the types of polynomials. Basically they have different types of degrees. So the main ones are, which we have seen before in lower classes. It is linear equations and of course quadratic equations. Okay. Linear equations are very simple. Highest power is 1, so 2x plus 3z, 3y plus 2z is 0 is a linear equation. Quadratic equations can be something like x squared plus 3x plus 5 equal to 0. Now, the important thing about quadratic equation are the roots of the quadratic equations. What do we mean by roots? Basically, if we have an expression such as this one, x squared plus 3x plus 5, we just need to know about the value of x for which this becomes 0. This entire expression becomes 0. So usually in quadratic equations we do not include other variables. So this is the general form, and let's just stick to this. Okay. So how do we find the root? There is a general formula for this, and if the roots are alpha and beta, these are two Greek letters by which we denote the roots of a quadratic equation. Usually there are two roots. They may also be equal, but there are two roots. So in that case, the roots are alpha or beta is minus b plus minus b square minus 4ac by 2a. This is the regular formula. So one thing we can learn from this is that if you take the plus part as alpha and minus part as beta, it doesn't matter which one you take, which one is what. Alpha plus beta will always be minus b by a, while alpha into beta will be c by a. What is a and what is b? What is b? What is a? What is c? What is a? So this is for the regular way of writing a quadratic equation, which is ax squared plus bx plus c is equal to 0. So in this case, alpha plus beta will be minus 3 by 1, as you can see here. And similarly, c by a will be 5 by 1. Okay. So this is the basic introduction of quadratic equations. We've already studied this in lower classes. We must have also studied a way to just factorize it without using this formula, but this is all fine. This is already done. This is just a short revision. Okay, so now we have just revised these variables basically a plus b the whole square and a minus b the whole square, a plus b the whole cube, a minus b the whole cube. But now, if somebody asks you, what is a plus b the power raised to 4? And it is tempting to, solve it like this, like, you take a plus b the whole square and then a plus b the whole square, and you expand every single term and figure out the answer. But there is a neater way to do this. And I will tell this to you using some very interesting theorem, which is known as the binomial theorem. But before we know what binomial theorem is, let us understand what a binomial expression is. So binomial expression is very simple. It comes from the word bi. It's just bi, and binomial would simply mean two terms. It could be anything. It could be 2x minus 3y, x plus 1 by z, 3 plus 9 by x, anything, doesn't matter. And then when we raise these two terms after adding them to some power, say x plus a raised to n, we have a general formula for that, and that is nc0 x raised to n plus nc1 x raised to n minus 1 a raised to 1, and so on until ncr x raised to n minus r a raised to r, and so on until finally ncn a raised to n. So if you are not familiar with this, this will be covered in the math syllabus. I'm not sure if I will be uploading any videos on mathematics right now, but yes, this I will just give you a very brief of what this is. So I hope we have all heard about what factorials are. N factorial. So a factorial is a symbol you put in front of a number such that the answer for that is the number times the number smaller than it times the number smaller than that, all the way up to 1. And right now for our syllabus, factorials are only true for non-negative integers, for positive integers and 0. So if we were to find out 4 factorial, it is simply 4 into 3 into 2 into 1, which is 24. Similarly, we have, say, some other number. So 10 factorial would be very large, but it would be 10 into 9 into 8 all the way up to 1. So these are what factorials are. Now what do we mean by this, what I've written, this symbol, NC0, NC1 and so on? So it is simply NCR. Any time when we write something like this, it can also be represented like this, N and R like this. This is basically N factorial by R factorial into N minus R factorial. So this is a very basic formula. I hope this is visible. I've written it in green. So this is a very basic formula, and why we have this formula, what is the use of it, will be studied in mathematics. But for now, we just need to understand this. So let's just calculate a very simple question where we calculate what is the value of it. 5c2 or 5(2) like this. Simply 5 factorial by 2 factorial into 5 minus 2, 3 factorial. And 5 into 4 into 3 into 2 into 1 can be written as 5 into 4 into 3 factorial. So let me just remove the equal to sign here. So this is 5 into 4 to 3 factorial by 2 factorial into 3 factorial. This gets cancelled. And 2 factorial is just 2 into 1, which is 2. So 2 2s are 4, and this is just 10. Simple enough. So this is just a formula. You don't have to actually memorize it. The more you move further into the course, it will automatically come to you. Okay, so this is the binomial theorem, as we have just seen. So now let us try to expand x plus a raised to 4, or even a plus b raised to 4, it doesn't really matter. So a plus b raised to 4 will be, so the simple pattern for this is, you start with n in the beginning, c, and you start with 0 and you go all the way up till n, and then you go from a raised to 0 to n, and b from n to 0. So this is basically how you write the formula. So let's just write it down. N is 4 in this case. The 4c0, a raised to 0, b raised to 4, plus 4c1, a raised to 1, b raised to 3, plus 4c2, a raised to 2, b raised to 2, plus 4c3, a raised to 3, b raised to 1, plus 4c4, a raised to 4, b raised to 0. Now don't worry about getting the order right. You might wonder which one is which, like, is a raised to 0 first or b raised to 0 first. Don't worry about it. This value and this value is the same. This value and this value is the same, and this is just a single value. Okay, so don't worry about it. I'm not talking about the entire, when I say the same thing, that is only true when a and b are the same. But what I really mean is, this part is the same, this part, not this entire a and b bit. So these values are the same. As you can see, 4c1 is equal to 4c3, as 4 factorial by 1 factorial 3 factorial is same as 4 factorial by 3 factorial 1 factorial. Simple enough. Okay, moving on. Let us understand what is the binomial equation for any exponent. We have just seen the exponent for non-negative integers. But what about any other number, like let's say 1 plus x raised to half? How do we find the expansion for something like this? So this expansion will have infinite number of terms, and it only works when it is of this form, basically, when x lies in between -1 and 1. So it cannot be 1 or -1 either. It is strictly in between it. And in that case, it is simply, I'll just write it down, 1 plus nx plus n into n minus 1 by 2 factorial plus n into n minus 1 n minus 2 by 3 factorial, and so on until infinite terms. So this is basically the same thing. If you think about it, if this was an integer, if n was an integer, we could have written nc2, and which is just n factorial by n minus 2 factorial into 2 factorial, which is n into n minus 1 by 2 factorial. So this is the same thing, except n is not an integer, so you cannot really write n factorial, so you write it in this form. Okay, so that is it for the theory part for now. Next lecture, we will be doing a few questions. Thank you for watching, and if you want me to make more of these videos, please write it down in the comments. I don't really care about likes or subscriptions or anything. I just want to know if you really want to watch it. Just let me know in the comments. That's the only way I can think of. Thank you for watching again. Goodbye. Have a good day.